Hi, in this tutorial I'm going to show you how to create the Onera M6 wing, and then we are going to mesh it with Snappyhexmesh. So the first thing is that we need a geometry. So if you Google search Onera M6 geometry and go to the NASA website, you will see down under the section geometry you will have something like airfoil text, and this is basically a text file with XY coordinates for the airfoil. This will consist only the upper section of the airfoil, so you can Control A and then copy this, and then we need to put that into a file and call this like onera.file. You can put it somewhere where you can find it later. So once you have this, we can go to the airfoil generator. You can import .files by dragging into this field or hitting browse, and then it will load the file automatically. One thing you need to check is the minimum and maximum x values, because this file right now is going from 0 to 1, and if you go to this page, it's somewhere with that one. No, page 38. Down here you will get basically to this page, and it is like 805.9. So 805.9, generate again and export the points. So once exported, we need a grid obviously, so it's on the XY plane. Let's update the spacing to 100. And the total size to 5000, something like that. If you zoom in, you will see that there is this one point missing, so I will hit Q and it will snap. When I left click, it will snap to the origin. So the next thing we need to check is we don't have a closing trailing point, so I will draw a reference line. So the next thing is I will close that. So once a curve is highlighted, I can hit the key S and it will snap to the curve, and I can hit the left mouse button and it will create a point on the curve. I don't need that anymore, so I'm going to delete it. So the next step is we need to create a spline out of this. So how to connect vertices. In the tool options, we are going to hit B spline, and the next thing is we need to select all the points. I will hold the key Shift, so Shift, and when I hold Shift and I hold the left mouse button, I can hover over all the shapes I want to group select or brush select, and I can remove my finger from the left mouse button and I can pan and drag the shape around, and then later hit Shift again and left mouse button, hover over the points, it will resume from where it stopped previously. So zoom out, do this again. It is much easier to stack the points that way. So brush select all of these, zoom in. So once we are done selecting, I will press the key E, and then I will hide the curve that we just created, box select, in the group, in the object tree, I can right click and group the points Onera top, so it will put into a directory or a group, so I can hide these and work with the curve. The next thing is, as you see already, the points are only for the top section from the NASA website. It has a symmetrical shape, so I'm going to mirror the bottom section. So I'm clicking on the curve. That is my target. I will click on the target button and you will see in the tool options that my selected count will go to 1. The next thing is I want to create the mirror plane. There are pre-selected mirror shapes like the XY, XZ and YZ planes. Hit XZ, preview will appear, hit E, that will accept, and hit escape. So I have like curve and the mirrored. Okay. Next thing is I want to control select both, so I can hit on this button stitch edges to wire. So what I have now is one closed wire. I can hit on that. I can create a surface out of that. So the next thing is we need a second airfoil at the end of the wing. So I will click on the XZ plane. And I need lots of reference lines as shown in this figure. So I will snap to the origin, and as for the angle, I will enter -60. That would create the 30 degrees in the drawing, and I don't know how long that's gonna be, so I will draw a long line. The next thing is angle 0 and length, that's 1578.7. Hit enter, hit E, that will accept, and then I need to find this cross section. So I am hovering, zoom in, hover over the recent line we created, and that I will hit the key O for orthogonal, and that it will lock I'm not sure if I hit correctly, so let me do it again. So I will start here, right, and then the next thing is I will hover over the edge and then hit key O, and it will lock the angle, and I will highlight the next edge, and then I will hit the key X for extend the boundary, and then I can left click and it will accept. So from here on I will hit the key R, it will reset, and from this part, the trailing edge endpoint, I will create another reference. I will go to here, hit escape, and now I should have my 3 lines in the drawing. The one thing that is missing is this distance B. So what I can do next is I can split. I can click on the split shapes button, and then I will click on this edge, and then I can move my cursor around, and then that will show one input field for length L and the ratio R. So I will hit key L and I will enter 1196.3 millimeters. Hit E and that will accept. So it did split my edge into 2 edges. Okay, I can hide this one and then you see this. The next step is create another reference line. So the angle is 180 and then I can hover over this and then hit X and then that will lock in. Left click, hit escape. So I know where I need to transfer the second airfoil now. I will click on the airfoil and that I will click on this copy selection button. That will create a copy of the file, of the face. So once I click on the face again, I can hit this button for scaling. And what I need is enter. I need to pass the selection with this button and you will see that the selected count will go up. And I will scale with the value of 0.56 according to this taper ratio and then hit E. And then I have my second airfoil that I will need to move to this part. I can do that like this. Transform button, hit selection, pass, and now I want to move the airfoil. The reference will be this point, so I will move I will select this front vertex and then attach the gizmo to that, and then I will hit on that vertex and that I will move the shape to this and I will hit the key E. And if I have done everything correctly, you should see that the airfoil will go from where it was previously to this, and it should normally go span this section. Obviously I did something wrong. Anyhow, let's proceed. So I have my two airfoils. This loft button enables shape selection. Select both, hit this button, and you can play around with these options if you want. So once you're satisfied with the preview, you can hit key E. That will create the wing. Hide the surfaces. So this is the Onera wing. So hit that, check the shape. It should be a valid shape. So the next thing is in this figure you see that the end is somehow rounded, I guess. I'm not quite sure. What you can do is if you want to add fillets, hit the fillet button. If you select this face and then hit this, hit the target button, it will create a preview. You can change the radius to something like 7 to get that. Oh, that was too much. Like 6. So 4 was okay, I guess. So hit E if you want. If not, it's also okay. So you will get a near rounded shape. I will reverse that. If you want, you can do that. So I created an OpenFOAM directory already in constant geometry. Let us select this, and then we will go to File, Export. You can copy the path, enter the path here. We want to create the STL file, so it's called loft. Let us change the name to Onera. So export once again, enter the path. Don't forget to select the shape, ASCII file, like medium for the triangulation quality. And then if you hit export, it will start exporting, and you will hopefully get a valid STL shape. If you want, you can open it with the 3D viewer in Windows. If you go to this, you will see it's a surface triangulation. Because of the curved section, you will have so many triangles, and the file size is like 15 megabytes, whatever. So the next thing is we go to Snappyhexmesh worksheet, and then the first thing we need is obviously a background mesh. For that, don't forget to import your Onera file, so you will see it in the list here. It is a wall. We need to create the refinement levels. We can do that after creating the background mesh. If you click on the button, a window will appear, and if you hit bounding box, you will see a box will appear. So we need to be careful. The Z maximum value needs to be like 0. And then the next thing is we need to extend to domain the cell size. If we change the surface mesh, you can see the cell size. And I think the chord length is something like 800. So let us change that to 10,000. Xmax to something like 20,000. Let's see how it would look like this. The Y value like minus 10,000 plus 10,000, then 1, 2, 3, then minus 10, maybe 10,000. If you want your fluid domain to be like this, if you're okay with that, you can zoom in, and you can see how many refinement levels you will need to get a good curvature on that. So if you like that, bounding box, hit on that directory. I have a directory set up already, so I will pass this. Okay. So in the systems you will see, you can either export the block mesh dictionary or export the mesh directly. When I do export directly, it is super fast. It will create the polymesh directory. And one thing, you can also change the patch names, like xmin would be like the inlet, I guess, and then the outlet, or whatever you want to call it. Minus maximum Z would be a symmetry boundary condition, so I will call it like symmetry Zeman will be like free stream or free slip if you want to mimic or emulate the wind tunnel, and the top and bottom would be like also free slip or free stream boundary condition, free slip, and then let me not duplicate the names. Export, close this, and if you want to look at your block mesh, you can drag and drop the foam file, hit accept, and then run, and that will load your mesh. And you will also see your boundary or patch files. So let me reset that. So the next thing to do is we need to tell where the material point is, where the domain is. So I will hit show sphere, this radius one, make it gigantic, it doesn't matter. Place it somewhere in the domain. What we need is the coordinates that we will derive. So if I remove these, I hit accept, you will see I have a background mesh. It's green, it was previously red. It will change the color. And the next thing we want is we want to create the Snappyhexmesh file, or don't forget the emesh file. So you have two possibilities to create the features edges file, or .emesh file it is called. I will do like this. I will create the surface features dictionary right now, and when I hit this export in systems files, the surface features dict will be created automatically. And for Onera geometry. So the next thing is basically I will activate if you want to create. Now we need to decide on how we want to refine the mesh. If I zoom in, like I will do like 4 refinements, and for the curvature I don't know, like 6, and for the future edges let me put like 5 or something like that. You can also decide on the distance, how you want to refine, and you will need to, if you want, tweak the settings. Like I have like 20 million I guess, where I kept the global cell size, so you can play around with these settings. If you want to create inflation layers, go into this tab, hit the name of the patch, let us create like something like 3 layers. It will probably collapse around these areas, but for demonstration purposes it's okay. So if I hit this SHM, it will say in the status bar it's generated. Don't forget to save your file. So if I save my settings, I can load them back. So it will create a JSON file and then the Snappyhexmesh file over here. So you can investigate the file, and let me run this thing in parallel with 4 cores. So I can check mesh to see the block mesh, the background mesh, and it might take a couple of seconds. Well, let me decompose the case, decompose part. Do not forget to run service features. And then run your mesh. Okay, it will take a while, I think, on 4 cores, but it's okay. So if you don't want to see the background mesh, you can hide it and you will see the geometry only. So I think the castellation step is over. And so the snapping process takes a while, and we can meanwhile investigate mesh after the castellation step. So I refine that around the curvature area. And after the snapping, it will create the layer. Okay, obviously it's adding the layers right now, so we can investigate the snap mesh right now. So after snapping, the mesh will look like this. We have like 1 million cells right now. I did refine this area. You may need to refine the wake area and maybe expand the area around the airfoil. I mean the refinement level. I did not change anything in the settings. You may need to tweak that, but for a short demonstration video that should be sufficient. That's taking quite a while right now. Meshing something like this with 4 cores is a little bit slow, it's resource intensive. I am recording on a free software, so sorry for that. You can skip this part. So it will terminate in a second. Okay, so it did add around 95% of the layers, so I think it collapsed around this area. Let's investigate. That's what I thought, because of the sharp edge. It did collapse right here. It's okay for this case. So I hope you liked this video, and sorry that it took so long. So I run. So mesh quality is alright. Let us check the quality here. So okay. So this is a tool with which you can investigate your mesh. Like you can compute the qualities in bin size. So then if you hit this somewhere, you can investigate like where did you screw up the settings. It's like here somewhere. I will check this update. You will see where the measure just basically screwed up. But the value of 70 is like excellent. So thanks for watching, and see you in our next video.